So now in the last video I explained this diagram. Now I'm going to actually demonstrate it. Make sure you click like, subscribe, and check out the links down below. They all help out a lot. I'm powering both these circuits with 9 volts right there. They both have about 15 milliamps of current going through them. That LED is just naturally a little bit brighter. Maybe I didn't use it as much or something. But in case there you can see we got about 15 milliamps of current going through that circuit. I moved this, you don't see any current because there was no current flowing. And we got about 15 milliamps of current flowing through that circuit. When red LEDs have current flowing through them, you can expect about 2 volts to build up across them. There we go. You can see pretty accurate there, 2 volts. We'll bend that one over. Let's see how well. Yeah, you can see the leads, and we will see that we got the same voltage across that one. You know, slightly different. Resistors, on the other hand, do not have a relatively fixed voltage across them. And so the red LED dropped about 2 volts, and this is a 470 ohm resistor. We got the rest of the voltage. 9 subtracting 2 is about 7 volts, as you can see there. Remember, it was slightly above 2 as well. So it makes sense that it was slightly below 7 there. And across the 2 of them there, you can see we got 7 volts. First, let's do the 330 ohm resistor on top. So they're dividing the voltage. There you can see we got about 4.7, a little less than 5 out of 7. So we're going to have a little more than 2 right here. As you can see there, the difference. So now we're going to measure resistance, so probably best turn the power supply off. Don't absolutely have to, because we're also going to remove the LEDs. You want to make sure that you isolate the resistors as much as possible. So now there's no current path. You need a continuous path for current to flow, and thus the only current we'll get will be through the 2 multimeter probes. So we measured voltage before, now we'll measure resistance. This is auto ranging meter, and we only need to move the red probe for high current with this particular meter right here. Other ones you're using, you may. So this is a 470 ohm resistor. These two are going to be the equivalent of 480, 330 plus 150. But remember, they always have tolerance. They're not 100% accurate. So it could be off, and I know it is. I took these measurements earlier. So there you can see a little bit shy of 470 right there. As I said before, this should be about 480 total. But there you can see we're falling shy again right there. Let's look at why. This is 330 ohms, and it's only given 320. So that's about 10 ohms short. And so we got about 4 ohms left. This is 150, but there you can see it's like 147. So somewhere about 4 ohms approximately, less right there. But a total of, you know, about 15 ohms less there. But any case, that's why they had a fraction of the voltage. They had the same resistance as that one there, so they had 7 volts total, just like that one basically, but that's only 150 ohms, and so it built up less of the voltage. It was a little more than like 2 volts, and then this one was like a little less than 5, as we saw before. But this is about 2/3 the resistance approximately of that one, and so it had about 2/3 the voltage, 5 out of 7 versus 7, and this one has about 1/3 of the resistance of that one, and so it had about 1/3 approximately, like 2.2 volts or so across it, as we saw before. Make sure you turn the meter off when you are done.